Long-held medical consensus links diets rich in animal products, particularly red meat and eggs, directly to cardiovascular disease. However, human cells do not process these foods in isolation. The damage depends on a hidden intermediary. This intermediary is a molecule called trimethylamine and oxide, or TMAO. Once known mainly as an obscure compound in marine biology, it has become a primary target for cardiovascular risk stratification. TMAO is a meta-organismal product. Its synthesis requires a relay between dietary precursors, the gut microbiota, and the liver. This discovery reframes heart disease as an ecological problem, a complex chemical dialogue occurring between a person and their internal microbial landscape. The metabolic relay begins in the intestinal lumen. After a meal, specific raw materials, primarily choline and L-carnitine, enter the gut. Specific microbial enzymes cleave these precursors to release a highly volatile gas called TMA. This malodorous intermediate serves as the raw material for TMAO. This TMA gas is absorbed across the intestinal wall and transported via the portal vein to the liver. This is a schematic of the liver's detoxification phase. An enzyme called FMO3, flavin-containing monooxygenase 3, oxidizes the toxic TMA into the systemically active TMAO. Host genetics play a decisive role. Polymorphisms that increase FMO3 activity can drive systemic TMAO levels higher, regardless of precursor intake. Once in circulation, TMAO impairs reverse cholesterol transport, essentially plugging the body's primary exit route for excess fats. Trapped in the arterial wall, macrophages overconsume modified LDL cholesterol until they swell into rigid, plaque-forming foam cells. TMAO also triggers vascular inflammation by activating the NLRP3 inflammasome inside the cells lining the blood vessels. The NLRP3 inflammasome is a protein complex that, when triggered, releases inflammatory cytokines that damage the arterial wall. Furthermore, the molecule acts as a prothrombotic sensitizer, forcing blood platelets to release their internal calcium stores. This sudden calcium release makes platelets hyperreactive. They clump together violently, accelerating clot formation under high shear flow conditions. This mortality hazard ratio chart visualizes the linear dose response associated with TMAO. For every 10 micromolar increment in the blood, all-cause mortality risk increases by roughly 7.6%. TMAO actively weaponizes the body against its own arteries, driving the progression of vascular injury and heart attacks independently of other risk factors. This historical reliance on seafood highlights a contradiction known as the fish paradox. Fish are rich in preformed TMAO, yet eating them is consistently cardioprotective. Fish-derived TMAO is transient and cleared quickly by the kidneys. It also comes packaged with anti-inflammatory omega-3 fatty acids that likely override any potential harm. Kidney function is the ultimate filter for these levels. When kidneys fail, TMAO pools in the bloodstream, reaching concentrations 30 times higher than normal. Effective risk assessment requires interpreting TMAO levels through the lens of renal health and dietary context. Dietary modulation serves as the first line of defense. Mediterranean and plant-based diets support a microbiome that naturally suppresses TMA-producing bacteria. To combat this, medical researchers are now developing precise pharmacological interventions that target the gut directly, non-lethal TMA lyase inhibitors. These inhibitors neutralize the specific microbial enzymes without killing the bacteria themselves. This targeted approach prevents TMA production while preserving the wider microbial community, avoiding the risk of antibiotic resistance. This opens the door to precision medicine, where a patient's unique microbial profile determines their specific nutritional and therapeutic needs. Long-term health depends on the precise management of this three-way chemistry between our diet, our microbes, and our own hearts.